Hey guys, welcome to Conceptual Geometry, lesson 5.8. We're going to do some more coordinate geometry triangle proofs. Example 1, prove triangle HJK is a right triangle. So remember, to do that, we need to show that a squared plus b squared equals c squared, where a and b are the two legs. So what we'll do first is find the distance of all three sides. And I'll start with HJ. So if I want to find the length of this side here using the distance formula, I make a right triangle, and I see that my delta y is 2 and my delta x is 3. I plug that into our distance formula. Square root 3 squared plus 2 squared. Now I recommend that you put this into your calculator right here, but these numbers are kind of easy. 3 squared is 9, 2 squared is 4, 9 plus 4 is 13. The length of that side is square root 13. Next, let's get JK. So for this side, make my right triangle, count the length of those sides, 1, 2, 3, 4 here for delta x, 1, 2, 3, 4, 5, 6 for delta y. So I have square root 4 squared plus 6 squared. 4 squared is 16, 6 squared is 36, 16 plus 36 gives me 52. So that side is square root 52. Our last side, HK, square root. All right, so I'm finding the length of this side. Let's make that right triangle. Delta y is 4, and delta x is 1, 2, 3, 4, 5, 6, 7. So that would be 7 squared plus 4 squared. Okay, so 7 squared is 49. 4 squared is 16. I add those together, I get square root 65. So now, what I have to show is that leg squared plus leg squared equals hypotenuse squared. Here are my two legs, and there's my hypotenuse. All right, so let's throw that into the formula. I like to use parentheses, square root 13 squared plus parentheses, square root 52 squared equals parentheses, square root 65 squared. Now what happens here, it's kind of neat, is this squared and the square root cancel out. So the square root of 13 squared is just 13. And that process happens again here. So the square root of 52 squared is just 52. And the square root of 65 squared is just 65. So now you ask yourself, is 13 plus 52 65? Yes. And our last step is to write our conclusion. I would say triangle HJK is right because, now we use the name of the legs, HJ squared plus JK squared equals HK squared. That's one of the more challenging proofs that we'll have, a right triangle. Now the next one, it gets even more challenging because it says prove triangle HJK is an isosceles right triangle. So we have to do two things. Number one, we have to show it's isosceles, which means two equal sides. And then we also have to show it's a right triangle. So that's like what we did up above. A squared plus b squared equals c squared. But regardless of the proof, we have to use the distance formula 3 times. All right, so I'll start here with HJ. Square root. So if I want to find the length of that side, I make the right triangle, count delta x and delta y. Delta y is 3. Delta x is 1, 2, 3, 4, 5. So I have 5 squared plus 3 squared. All right, so that's 25, that's 9, add them together, that gives me 34. So the length of that side is square root 34. Next, JK. Square root, all right, so here's JK. Count those, this is 3, 1, 2, 3, that's 5. So it doesn't matter what order you put these numbers. If you notice, it's 3 squared and 5 squared, just like above, so that's got to be square root 34. What I notice here right away, those two are equal. So HJ equals JK. We still need to find the third side. That's the length of HK. All right, so that's this side here. Make our right triangle. Delta y is 2, and delta x is 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 squared plus 2 squared. 8 squared is 64. 2 squared is 4. So that would give me square root of 68. Okay, let's use our Pythagorean theorem. Parentheses, square root 34 squared plus parentheses, square root 34 squared equals parentheses, square root 68 squared. Remember, the squared and the square root cancel out, so this gives me 34 plus 34 equals 68, and indeed, 34 plus 34 does equal 68. So now, my conclusion has to involve two parts. It must mention that it's a right triangle and explain why, and that it's an isosceles triangle and explain why. So I will say triangle HJK is right because HJ squared plus JK squared equals HK squared, and isosceles because it has two equal sides. So that is as long a proof as I can ask you in this unit, combining the right triangle with isosceles or with a scalene. All right, one last example. This one will go quick because it is just a scalene triangle. So prove that triangle HJK is scalene. Remember, that means no equal sides. All right, so we're going to do three distances. Let's start with JK. So that's this side here. So delta x is 1, delta y is 3. 1 squared plus 3 squared. 1 squared is 1, 3 squared is 9. Add those together, you get square root 10. Next, HJ. Okay, so HJ, a little hard to see here, but I'm going to make a right triangle. Delta y in this case is 2. Delta x is 1, 2, 3, 4, 5, 6, 7. So I get 7 squared plus 2 squared. 7 squared is 49. 2 squared is 4. Add those together, you get square root 53. And lastly, HK. All right, so that one is a little bit longer. These numbers will be bigger, obviously. Make your triangle. Delta y, 1, 2, 3, 4 is 5. Delta x is 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 squared plus 5 squared. Let's see, 8 squared is 64. 5 squared is 25. Add those together, you get 89. Square root 89. Now this one's kind of easy, like we said. Scalene doesn't have any equal sides, and just comparing these, none of these are equal. So our conclusion is pretty simple. Triangle HJK is scalene because it has no equal sides. All right, guys, that concludes day 8. That's the last lesson of this unit. You're now well equipped to do homework worksheet 8 and start preparing for our unit exam in a few days. So thanks a lot for watching. As usual, reach out if you have any questions, and we'll see you in class soon.